Here is a fact that should blow your mind. Before MCP, every AI agent team had to invent their own custom protocol just to let an LLM call an external tool. That meant hundreds of incompatible integrations, brittle code, and months of wasted engineering time. The Model Context Protocol, MCP, fixes this by giving every AI agent and every tool a shared language to communicate. Think of it like USB-C for AI. One standard connector, infinite devices. In this video, you are going to build a real MCP-powered agent in JavaScript that fetches livestock prices from a financial API and uses an LLM to summarize the market outlook. You will understand exactly how the MCP client-server loop works, how tools get registered, and how the model decides which tool to invoke. Whether you are building a trading assistant, a DevOps bot, or a research agent, this architecture is the foundation you need. Before we write a single line of code, let us make sure your environment is ready. You will need Node.js 22 or higher, because MCP relies on native async iterators and the built-in fetch API that's stabilized in that release. First, install the official MCP JavaScript SDK. That is the package that gives you the server, client, and type definitions out of the box. Next, install the Anthropic Claude SDK, which is our LLM backbone in this example. Claude 3.7 natively understands MCP tool schemas, so the integration is seamless. You will also need Axios to make the financial data request to the Alpaca Markets API, which offers a free tier with real-time quotes. Finally, install .env so you can keep your API keys out of source code. Create a fresh directory called MCP stock agent, run npm init-y, then install all 4 packages in one command. Your package.json should target ES modules, so add type module to it right now. Now the fun part, you are going to build 2 files, server.js, which exposes the stock price tool over MCP, and agent.js, which runs the LLM loop. Start by importing the MCP server class and creating an instance with a name and version. Then call server.tool to register a handler named getStockQuote. The schema you pass is a plain JSON schema object describing the ticker parameter. MCP serializes this automatically so the LLM can read it. Inside the handler, you make an Axios get request to Alpaca's v2 quotes endpoint using the ticker the model provided. You return a structured content array with type text and the formatted price string. In agent.js, import the MCP client and the Anthropic SDK. Create an in-process client, connect it to your server using the in-memory transport, then list the available tools and pass them straight into the Claude Messages call. The model will call getStockQuote automatically when a user asks about a stock. A production agent needs to handle 3 real failure modes: an invalid ticker symbol, a network timeout, and a rate limit response from Alpaca. Let us harden the tool handler right now. First, add a regex guard at the top of the handler. If the ticker does not match 1 to 5 uppercase letters, throw an MCP user error immediately. That tells the LLM the input was wrong, so it can self-correct rather than retrying indefinitely. Wrap the Axios call in a try-catch. On a 429 status code, return a soft error message inside the content array so the agent can tell the user to wait and retry. For the agent loop, enable streaming on the Claude call by setting stream to true and using an async for-of loop over the response. This means the user sees tokens appear in real time instead of waiting for the full summary. Finally, add a finally block that always calls client.close and server.close to prevent resource leaks in long-running processes. Let us lock in what you just learned. MCP is not a library trick. It is an open industry standard that separates tool logic from model logic, which means your tools are reusable across Claude, GPT-5, Gemini Ultra 2, and any future model that speaks MCP. You built a server that exposes a real financial data tool, a client that drives an LLM conversation loop, and a hardened error path that keeps your agent from looping forever on bad inputs. The 3 most common mistakes developers make are registering tools without strict input schemas, forgetting to close transports and leaking file descriptors, and returning raw error stack traces inside content arrays which confuse the model. For your next project, try chaining 2 MCP tools together. For example, fetch the stock quote, and then call a second tool that writes a buy or sell signal into a Notion database. The architecture scales exactly the same way. If this helped you, smash the like button and subscribe for more tutorials every week.